Hello everyone, this is the first lesson recording for IM2, March 15th, 2021. Few announcements, next few days. What are we doing today? We are going to relay solving quadratic equations with quadratic functions and interpretation of exponents. Next class, we're going to be doing some review or extension, depending on whether you need to be doing more review or whether you can be challenged to do more extension. On Monday, there will be the Unit 8 test that is culminating on the solving of quadratic equations, including complex numbers. So let's review roots of functions. This is Desmos activity card number 1. So from last lesson, we defined roots to be values of input that gives output to be 0. That means we are looking for values of x that gives the y to be 0. So basically, in this case, we're solving for this equation when we set y to be 0. So the roots for this equation will be x is equal to -4 and x is equal to 4. And you're going to explain that here. So definition of roots of functions are input values that gives an output of 0. So what are the roots of function g of x is x plus 4 times x minus 4 going to be? We want to find the x values that give the output of 0. So g of x is x plus 4, x minus 4. So we are going to let the equation to be equal to 0. And the roots of the function are the solution to the equation, which is going to be x is equal to 4 and x is equal to -4. And one of the students asked in the Desmos activity, are the roots always the same as the solutions? Yes, they are always the same as long as you are looking for the solution for the equation that is equal to 0. So then let's relate the functions roots to graphs. So that's card number 2 and 3, and that is a review of, it's actually the same card that you did last class. I should say similar. Okay, card number 2. Imba and Mahdi are working together and finding roots for f of x is equal to 4 multiplied by x plus 3 all squared. Imba said the roots are x is equal to 2 and x is equal to -12. Mahdi said the roots are x is equal to -3 and x is equal to 3. Who do you agree with? Well, let's solve this. Okay, so first we're looking for values of x that gives the output to be 0. That means f of x is 0. So I can set this equation as 4 multiplied by x plus 3 all squared is equal to 0. Okay, now what is the best method to solve this? We can use square rooting, right? We can divide both sides by 4 to get rid of this, and that leaves me with x plus 3 all squared is equal to 0. And then from here, I can take a square root of both sides to cancel out the squaring and square out. And that leaves me with x plus 3 is equal to, what is square root of 0? That's just going to be 0. The plus or minus does not take into effect because 0, there is no positive 0 and -0. That means from here I have x plus 3 is equal to 0. So I'm going to bring 3 to the other side by subtracting 3, and you get x is equal to -3. Now, Imba said 12 and -12. My only solution is x is equal to -3. Not even positive 3 and -3. It's just one solution. So I am going to say it is neither. Okay, and you can explain your thinking. You can say, when I try to solve this, I first divide by 4 and then take square root of both sides, and I found my solution to be -3, and I only got one solution. So Mahdi is incorrect and Imba is incorrect. Okay, so here are the graphs of three functions and the graph roots. What do you notice about roots in the functions graph? Okay, so with this graph, y is equal to x squared minus 4x plus 3, we have two roots, 3 and 1. That's where the graph is crossing the x-axis, 3 and 1. In this case, we only have one root at 2. Okay, that's where the graph is touching the x-axis. In this case, we only have complex roots, no real roots. So this is where we don't have any x-intercepts. So when we don't have any x-intercepts, then we can say that there are no real roots, which means that there are two complex roots. And that has been summarized in this slide. So we can say real roots are the same thing as x-intercepts, and complex roots have no x-intercepts. So that means that roots in graph, if there are x-intercepts, there are roots of the functions. These roots are real numbers, and we can have one or two roots, or one or two x-intercepts. If there are no x-intercepts, the roots are complex numbers, and roots are also sometimes called zeros of the function. So solutions, roots, and zeros, they all mean the same thing. Okay, so solution to the equation that is set to equal to 0, x-intercept, roots, zeros, they all mean the same thing. So the function's roots in graphs, you are going to be doing Desmos activity card number 4 to 7 now. Okay, card number 4 says sketch a quadratic function that has one root. Okay, how can you get one root? That's where the graph just touches the x-axis. That means it never crosses. So let's just say I could make it look like this. And remember, parabolas are pretty symmetrical. So you do want it to be symmetrical somewhat. Okay, so that will be, it only has one root. It touches the x-axis only once. It does not go over to the other side. Okay, so we are asked to sketch a quadratic function that has two complex roots. Two complex roots means there are no real roots. That means we do not have any x-intercepts. So I could graph any function that never crosses or even touches the x-axis. So it's a floating parabola. Okay, then sketch a quadratic function that has two real roots. If it means two real roots, that means we have a parabola that is going through, and my parabola does not look very symmetrical, but here is one root and here is another root. Okay, it does not have to go through an integer or whole number exactly. It can be anywhere in between. Okay, now we are going to be doing some card sort, and we're going to be matching graphs with the equations and the number of roots. So what do we have here? We have one graph here, another graph here, and a third graph here. Okay, so looking at this is my floating parabola. That means we do not have any x-intercepts, and which means that we only have complex roots. So here is a complex root. Okay, and what about here? Okay, the root, the x value at which it touches the x-axis is -4. Okay, so x is equal to -4 is the root. And it looks like I've made a mistake, and it should be, yeah, it does not quite match. It should be -4. And roots are 4 and -2. Roots are 4 and -2. Okay, so I did not want to match that. Roots are 4 and -2, so the intervals are 2, 4, 6, 8, so that's 4 and -2 are my roots here. Okay, so then what are my equations? Okay, x minus 4 all squared plus 2. X minus 4 all squared plus 2. If I take a square root of both sides, bring this to the other side, that's going to be x minus 4 all squared is -2. And that's going to leave me with imaginary numbers because I'm taking a square root of negative numbers. So this is going to be my complex roots. And let's see what we have here. So x minus 4, x minus 4. So that would give my roots to be +4, +4. But actually, this is not quite right. I am going to fix that on the actual the decimals, and this would be x minus, it would be x plus 4, no, x minus 4 and x times x plus 2, which will be this. Okay, we're going to shift gear a little bit and we're going to be simplifying exponents. So I'd like you to tell me in private chat, what is 3 to the power of 4 times 3 to the power of 5? What is that equal to 3 to the power of what? Well, since the bases are the same and we are raising it to the power of 4 and 3 to the power of 5, this 3, so you can just add the exponents and that's 3 to the power of 9. Remember, the reason this works is 3 to the power of 4 is same as 3 times 3 times 3 times 3. And 3 to the power of 5 is multiplying 3, 2, 3, 4, 5. Okay, so you can think of it as 3 is being multiplied 5 times and then 3 is being multiplied 4 times more. So you can say that you can just add the exponents and that becomes 3 to the power of 4 times plus 5, which is same as 9. So this is the power product or product law of exponent law. What about this? If you have 3 to the power of 4 to the power of 5, all raised to the power of 5, what is that equivalent to 3 to the power of what? Well, it is same as 3 to the power of 4 multiplied by 5, which is to the 3 to the power of 20. What does it mean? Why does this work? Because 3 to the power of 4, does this work? That's because when something is being raised to the power of 4, whatever is in the parentheses is being multiplied to itself 5 times. So this is same as 3 to the power of 4. That's what's inside the parentheses. Whatever is in the parentheses is multiplied to itself 5 times, and each of the parentheses is 3 to the power of 4. That means since the bases are the same, we are adding 4 plus 4 plus 4 plus 4 plus 4, or 4 multiplied to itself 5, multiplied to 5, which is 4 times 5, which is 20. So this is same as 3 to the power of 20. Next, 3 to the power of 8 divided by 3 to the power of 4. What is that equivalent to? 3 to the power of what? And the answer is, you can subtract. This is the quotient law of the exponent law. So it's 3 to the power of 8 minus 2, which is equal to 3 to the power of 6. Why does this work? This works because 3 to the power of 8, 3 to the power, Why does it work is that when you have 3 to the power of 8, that means 3 is being multiplied to itself 8 times. Divided by 3 to the power of 4 means 3 is being multiplied to itself 4 times. And we know that numerator and denominator, because they have just been multiplied, they can cancel out. So however there are of the same base as a denominator, you can subtract however many there are in the numerator. That's what we are doing. We are subtracting. Okay, so, and this is an error here. It should be minus 4. and it should be 3 to the power